Good morning everyone, my name is GIM and I'm here today with my co-author GIM from GuideWave Analysis LLC in San Antonio, Texas. Our paper is titled Advancing GuideWave Inspection Reports Toward Per-Inspection Documentation, a new reporting framework for the GIM software. We are going to talk about the specific practical problem in how the GuideWave testing inspection reports are currently written and show you the solution we have built into GIM version 7. Here is the structure of today's presentation. We'll begin with a brief background on GuideWave testing and the MSS system, then describe the reporting gap that motivated this work. We'll introduce the GIM software, then work through a live software demonstration using a real pipeline inspection data set. After the demonstration, we'll cover the technical features in detail, the indication report, the T01 mode confirmation evidence, and the section detail feature. We'll close with the conclusion and path forward for GuideWave testing reporting standards. For those who may be newer to GWT, I want to establish a few key points. GWT using main descriptive sensor and the MSS system generates the nondispersive T01 torsional wave mode at the probe location. This wave travels along the pipeline in both directions and reflects from geometric features, welds, and anomalies. The key practical advantage is range. From a single probe location, we can screen 100 to 300 feet over pipeline. This makes GWT uniquely suited for buried pipeline, insulated lines, and sections that are otherwise difficult to access. The nondispersive nature of T01 mode, meaning all frequency components travel at the same velocity, is essential. It is what allows us to precisely locate indications by distance, and it is a physical basis for mode confirmation using the spectrogram, which we'll come back to. Now, here is the problems. The slide shows a direct comparison between current GWT recording practice on the left and the standard practice in other NDE methods on the right. In conventional UT, phase ray UT, time of flight diffraction, and magnetic flux leakage inspection, every detected indication has its own dedicated report page. The client receives tabulated data for each finding, physical evidence images embedded in the report, and open a field photograph tied to that specific indication. The Level 3 reviewer can assess each indication independently. In GWT, the standard report delivers the entire inspection on one or two full-length data plot pages, with marks overlaid on the trace. Individual indications receive no indication pages, no tabulated reflection coefficient or SN ratio at each frequency, no spectrogram image as a physical evidence, and no mechanism to attach a field photograph to a specific finding. This gap exists not because GWT cannot provide this information, it can, but because the software tools to generate per indication documentation have not been part of the standard reporting workflow. GIM version 7 is designed to close that gap directly. GIM stands for GuideWave Inspection and Monitoring. It is a semi-automatic data acquisition, analysis, and reporting tool developed for use with the MSS GuideWave system. GIM version 1 through 6 produced what we call the summary report, a pipeline schematics, full-length TCG data plot at each center frequency, and indication marks. Those earlier versions did include a UT image tool in the review screen, but it was a review tool for analysis only. It was not part of the report output delivered to client. GIM version 7 introduces the UT detail menu. This contains 3 new sub-menus: indication report, section detail, and export to PDF. Together, they generate per indication and per section detailed report pages compiled as a PDF file that accompanies the summary report in the final inspection package. Let me now show you this in action with a real data set. This is the pipeline used for demonstration today. It is a 4 NPS Schedule 120 pipe, 4.5 inches outer diameter, and 0.438 inches wall thickness, wrapped with a calcium silicate insulation. This is a retired pipeline, and as you can see from the photographs, it has inner surface corrosion. These are exactly the conditions for which GWT is well suited. Insulated with non-wall loss anomalies to detect and document. Here you can see the MSS probe installed on the pipe using a dry coupling tool. The probe is centered in the frame. One important detail to note, there is a weld located at approximately 0.76 feet from the probe. This is significant because it will generate a more converted T02 signal that will lead to identify and distinguish from real anomaly indications. This weld will become the central example for our mode confirmation discussion. Now let me walk you through the GIM version 7 software using this dataset. This is a welcome screen of GIM version 7. I'll go directly to the Review and Report section, which is where the new UT detail features live. This is a review subsection. The data was acquired at 4 center frequencies, 32, 64, 90, and 128 kHz. After calibrating distance, amplitude, and attenuation, 9 indications were detected and marked. You can see the full-length TCG data plot with all indication marks. This is what the standard GWT report would deliver. The complete inspection picture on one page. Now let me take you into the UT detail section to show what happens next. This is the UT detail plot. For each mark, it shows the spectrogram, which is frequency content versus distance, alongside the FFT plot of the selected signal. The key thing I want you to understand is this. The T01 mode is nondispersive, meaning all frequency components travel at the same speed. In the spectrogram, a nondispersive T01 reflection appears as a vertical line at the indication location. That vertical line is physical evidence. This slide shows the detailed UT plot for weld reflection at each frequency, 64, 90, and 128 kHz. Look at the spectrogram. It is a clean vertical column at the weld location. That is a nondispersive T01 mode. The FFT plots show the Gaussian frequency distribution centered on each probe frequency. This is the signature of the transmitted T01 mode. Why does this matter? Because this weld reflection is our reference. Any real pipeline indication, a corrosion anomaly, a crack, should show similar vertical spectrogram and similar FFT profile. If a spectrogram is not vertical or if the FFT center frequency has shifted, something else is happening. This is the torsional mode dispersion curve tool built into GIM software calculated for this exact pipe with a 0.438 inch wall thickness. The flat horizontal line at approximately 128 inches per millisecond is a T01 mode. It is non-dispersive. Its velocity does not change with the frequency across the entire range from 0 to 250 kHz. That flat line is why the spectrogram shows a vertical column. Every frequency arrives at the same time at the same location. The curved line is a T02 mode. It has a cutoff frequency of 146.1 kHz. Below that frequency, T02 does not propagate at all. Above the cutoff frequency, it propagates, but Its velocity increases with the frequency. That is what makes it dispersive. GIM calculates this and tells the analyst directly. The cutoff is between 128 and 180 kHz, so check for T02 noise when using 128 kHz probe. Now let me show you exactly what that looks like in the spectrogram of the EX1 signal. Now this is very instructive. This slide shows what we labeled EX1 on extraneous mode generated by mode conversion at the W1 weld. This is a T02 mode. Look at the video data plot. The signal is wide. Look at the spectrogram. Instead of the vertical column, you see a curved sloped band. The FFT plot shows the center frequency has shifted away from the probe frequency. These are all classic signatures of the dispersive T02 mode. Here is an important physical point. The EX1 signal appears at a location that is delayed relative to the W1 weld position. Even though the weld is only 0.76 feet from the probe, the dispersive T02 energy has spread considerably over that short distance. This is exactly the dispersive behavior described by the T02 cutoff frequency of 146.1 kHz for this pipe wall thickness. At distances of 10 feet or more from a geometric feature, dispersive mode converted energy spreads so far that its amplitude falls behind the background noise and becomes undetectable in practice. This shows the 128 kHz data plot, and I want to draw your attention to side-by-side comparison of the EX1 signal and the W1 weld signal. By displaying them together at the same scale, you can directly see the difference in the frequency spectrogram of each signal. The weld shows a symmetric Gaussian distribution centered on 128 kHz. The EX1 T02 signal does not. This comparison is one of the practical tools analysts use to identify mode-converted signal in the field. Moving to the report subsection, this is where we set the pipe information, inspection summary, and inspection range. The input that defines the head information for the standard GWT report. Here we set the y-axis scale for individual data plots in the TCG and DEC curve output. Once all settings are confirmed, clicking Generate Report produces the standard GWT inspection report. This is the standard GWT inspection report, the output that GIM has always produced. It contains basic pipeline information, a written summary, an indication table, a pipeline drawing with marks, and full-length data plots at each frequency. This report is thorough for pipeline level coverage, but as we discussed, each individual mark on these plots has no dedicated documentation page. That is what we add with the UT detail features. Each frequency also has a data trace report page showing the spectrogram, the full video data plot with the DEC curves, and the TCG plot with all indication marks. This is the conventional reporting format. Now, we move into the UT detail chapter, the new section in GIM version 7. Here, for each indication I want to document in detail, I can adjust the x-axis width shown in the plot, yet the y-axis scale, and attach the field photograph using a photo insert button. The analyst selects marks individually or adds them by symbol type. For example, all Q-type anomaly marks at once. When everything is set, this generates the dedicated indication report page for that mark. This is the section detail feature. I have selected a range from -4.71 to 1.47 feet, a section that includes the W1 weld and the nearby area. What makes a section detail particularly valuable is the high spatial resolution of the spectrogram view within a focused distance range. Look at this plot. The EX1 extraneous mode signal generated by mode conversion at W1 is clearly visible as a sloped curved feature, completely distinct from the vertical columns of the T01 reflections. This is an excellent tool for differentiating real indications from mode-converted artifacts in complex regions of the pipe, such as near pipe spots or closely spaced welds. These are examples of the actual indication report and the section detail report pages as they appear in the final PDF output. In each case, the spectrogram shows a vertical column at the indication location, confirming the nondispersive T01 mode. This is a key advance. Instead of the analyst knowing this information during the analysis, but it never appearing in the delivered report, it is now embedded in the report itself, visible to the client and to the Level 3 reviewer. Let me now summarize the indication report feature for you. Each selected indication generates a dedicated one-page report with 6 components. The page title identifies the indication by symbol, number, distance, and amplitude, in magenta for Q-type anomaly indication and blue for W-type geometric feature such as welds. The data table shows the center frequency, location, reflection coefficient, and signal-to-noise ratio at each frequency. The highest reflection coefficient is highlighted in red. The highest signal-to-noise ratio is highlighted in blue. The signal plot shows 3 columns at each frequency: the TCG video plot, the rectified RF, and the spectrogram with the FFT curve overlaid in yellow. The auto-generated comment provides estimated cross-sectional area, wall loss, axial length, and the T01 mode confirmation statement. The analyst can edit this comment. An optional field photograph can be attached directly to the indication page. Here is a concrete example. Indication report page for Q8 detected at minus 4.13 feet with a maximum reflection coefficient of 1.84% at 128 kHz. Look at the data table. The highest reflection coefficient, 1.84%, is at 128 kHz and the highest in red. The highest signal-to-noise ratio, 8.18, is at 64 kHz and highlighted in blue. These two numbers tell a different story about this indication, and the indication report captures both. The auto-generated comment reads estimated cross-sectional area approximately 1.8%, estimated wall loss approximately 25.2%, with axial length estimate from the coral wavelength at the peak frequency, and the T01 mode confirmation via the nondispersive spectrogram. Why does SN ratio matter separately from reflection coefficient? Because the frequency with the best signal quality for classification may not be the same as the one with the highest amplitude. Both are reported, giving the analyst and the reviewer the complete picture. I want to spend a moment on the physical basis for mode confirmation, because this is what makes the spectrogram evidence meaningful. The T01 torsional mode is nondispersive across the frequency range we use for standard pipe inspection, approximately 10 to 250 kHz. All frequency components travel at the same speed. In the spectrogram, which shows a frequency content versus distance, a nondispersive T01 reflection appears as a vertical line at the indication location. When FFT overlay traces through that vertical band, it is a direct physical evidence that you have detected a real T01 reflection. By contrast, The T02 mode, which is produced by mode conversion at the large geometry feature, is dispersive. Different frequencies travel at different speeds. In the spectrogram, it appears as curved or sloped band. As I showed with the EX1 example, this is clearly distinguishable from the vertical T01 signature. By including this spectrogram with the FFT overlay on every indication report page, GIM version 7 gives the client, the approving examiner, and any further reviewer direct access to this mode classification evidence, not just to analyze the written statement that the mode was confirmed. The section detail feature complements the indication report by providing focused documentation of a selected pipe section rather than a single indication. The analyst presses the range insert button and clicks 2 points on the video data plot to define the section boundaries. The software generates a report page showing multi-frequency RF data and spectrogram plots across the entire selected range, with all indication marks within that range displayed on every frequency plot. An optional field photograph can be attached with a user-supplied caption. This is particularly useful for pipe spots, areas of non-complexity, or any sections that warrant independent documentation beyond the individual indication pages. You saw this in the demonstration. The section detail plot between -4.71 and 1.47 feet gave us a clear high-resolution view of both T01 reflection and the T02 extraneous mode from the nearby well, all in one focused report page. This table summarizes the difference between GIM version 6 and GIM version 7 across 8 reporting capabilities. Every single item in the left column per indication report pages, data tables, estimated cross-sectional area and wall loss per indication comments, field photographs, T01 mode visual evidence, section-specific detail pages, and UT detail in PDF output was either not available or was limited to analyst review screen in version 6. In version 7, every one of these is a standard part of the report output. The client and the level 3 reviewer receive all of these in the UT image PDF file alongside the standard summary report. This is a concrete and measurable upgrade in the reporting capability. I want to make 3 points about the broader implications on this work. First, large area coverage and per indication detail are complementary, not competing. The long-range capability of guide wave testing is the technical basis for finding indication efficiently. Once found, there is no technical reasons why each finding cannot be documented with the same rigor used in other NDE methods. The summary report continues to document the full pipeline coverage. The UT detail report documents each individual finding. Both are submitted together. Second, this changes what a client receives. A client reviewing a GWT report is primarily asking, is there a defect in my pipeline? And if so, what should I do? The indication report page answers this directly with quantified data, sizing estimates, and physical mode confirmation evidence. This is the same standard of communication that clients receive from the PAUT, TOFD, and MFL reports. Third, for the level 3 reviewer, the indication report page provides direct access to the spectrogram and FFT evidence for each finding without requiring a reanalysis of the raw data. This makes the review process both fast and more rigorous. 5 conclusions from this work. 1. The long-range coverage of GWT is a basis for finding indications, not a reason to limit the report to single full-length plot. 2. The indication report features in GIM version 7 provides a dedicated page per indication with a data table, auto-generated sizing estimate, an optional field photograph, and a spectrogram plot with FFT overlay. 3. The spectrogram FFT overlay provides a direct physical evidence of T01 mode confirmation for every reported indication. 4. The section detail feature enables a focused documentation of specific pipe sections or critical areas. 5. We encourage the guided web testing community to consider adopting per indication documentation as a standard reporting requirement. This would improve consistency, credibility, and transparency across the industry and bring GWT reporting in line with the standard that already exists in other established NDE methods. Thank you for your attention. If your company would like to learn more about the GIM version 7, MSS guided web testing equipment, training courses, or consulting services, please contact me at askim@gwanalysis.com. I'm happy to schedule a Microsoft Teams meeting to demonstrate the software with your own data and answer any questions from your team. Thank you for watching. If this video was helpful, please subscribe. We are releasing more GIM version 7 technical content regularly.